Yes, now it is visible, sir.
All right, that's brilliant. So close this. Okay, so today I'm going to be talking about super directive antenna arrays, which I believe it's an old concept that has never really found, has never really attracted enough attention because of some fundamental challenges. But now I think with the knowledge we have in the context of massive MIMO and antenna array design, it makes perfect sense to go back to that old idea and try to revisit the fundamental principles. Okay. So before I start, I would like to spend the first 5 minutes introducing, our Center for Wireless Innovation here at Queen's University Belfast, the work we do, so that the audience gets a better idea of the place I work for, and maybe can stimulate further collaborations in this space. So CWI was formed officially in 2016 through the consolidation of research expertise into research clusters, as you call them here, one in high-frequency electronics and the other one in wireless communications. This doesn't mean that, we are, CWI is, of course, officially, a junior center, but Queen's University Belfast has a long-standing experience in wireless communications going back to the 70s. A number of important breakthroughs were developed here, particularly in the space, in the satellite space. At the moment, CWI is the UK's largest research, development, and exploitation base in physical layer wireless, and technically we are one of the strongest group in wireless in Europe. This is evidenced by our consistent ranking within the top 75 groups in the world, according to the Shanghai rankings. Right now, we are ranked 8th in the UK in this prestigious ranking table. And the moment the center is home to around 55 people, including academics, postdoctoral researchers, PhD students, engineers, and also administration staff. Okay. Now, the work we do is quite broad. It spans fundamental communications modeling all the way to physical prototyping. And the vision of CWI is to develop truly disruptive end-to-end physical layer wireless technologies and techniques that will assist in the creation of a data-driven, hyper-connected society. We work across RF, 2mm, and even terahertz bands. And the applications of our solution can improve coverage, data rate, latency, security, connectivity on a massive scale, or even can find application in wireless imaging and sensing. What I would like to articulate here is that CWI has unique lab facilities that can only be found in an industrial environment. Instead, here in an academic environment, through continuous investment over the past 30 years, we have managed to create some of the state-of-the-art lab facilities. This, for instance, include the recently renovated anechoic chamber, in which we can measure, we can implement measurements up to 110 gigahertz. And we are also home for one of the unique Keysight labs in academic environment that is a non-linear millimeter wave lab. There are two there are two labs like this in the world. One is in Queen's University Belfast, and the other one is at the University of Barcelona in Spain. All right. Now, these are some of our industrial collaborators. You can see some very big names, the likes of Ericsson, Samsung, Nokia, Bell Labs, Huawei, Intel, and so on and so forth. DSTL is the research arm of the British Ministry of Defence. Kinetic is, of course, is also affiliated with the British Ministry of Defence. and we also have the European Space Agency. My collaborators have been historically working with European Space Agency for nearly 25 years, and we have developed surfaces, frequency selective surfaces, and also retrodirective antenna arrays suitable for space applications. These are some of our academic collaborators, spanning all four corners of the world. So the likes of Stanford in the US, in University of South Carolina, University of Washington, and going to the other side of the world, we have close collaboration with University of Wellington in New Zealand, also in Asia with Southeast University in China, which is the top university in mobile communication in China, HKUST in Hong Kong, and so on and so forth. The list is very long. So in case you are interested in working with us, please drop me an email and we can, kickstart an official collaboration, all right? Now, a little bit about myself, although the first speaker introduced me briefly. I got my PhD from University of Edinburgh in 2008, and since 2013, I'm with Queen's University Belfast, first as a senior lecturer, then as a reader, and since 2020, I'm a chair professor of communication engineering and signal processing, and also the deputy director of the Center for Wireless Innovation. These are some of my recent achievements, scientific achievements. This is the ceremony for the 2019 EuroShip Early Career Award, and these are some publicity that came after my ERC grant. This slide highlights who I am and what I'm doing from a research perspective. So my research is actually on the interface of these four research spheres: signal processing, communication theory, electromagnetic theory, and wireless communication. So I work on the interface of these four spheres, okay? And my core expertise is in massive MIMO and what comes after massive MIMO, the likes of intelligent reflecting surfaces, cell-free massive MIMO, millimeter wave and terahertz communications. But we also do some work on algorithmic sides of the likes of machine learning for communications. I have one visiting student from China working on this at the moment. And in the past, we've done a lot of work on radiometrics theory, distributed MIMO systems, and low complexity MIMO detection, okay? Now, so let me start, talking about antenna, typical antenna array design, all right? So the way that antenna arrays have been designed is that we take a number of antenna elements and we place them most frequently at half a wavelength apart from each other in order to avoid mutual coupling. And then we do some sort of maximum ratio transmission. So we focus our beam towards a desired direction, towards a desired user. And in theory, once you do this, we know from fundamental antenna theory that the power gain scales with the number of antennas in a linear fashion. Now, the pitfalls of this solution is that minimal mutual coupling is hard to achieve in practice. You need to space the antennas quite far away from each other. And we know that, for instance, in massive MIMO, there are space constraints. Okay, you cannot keep increasing the antenna spacing for as much as you want because you are going to run out of space. That's not a sustainable solution. And also, another question that always has bothered me is, can we do anything better than this linear increase? Okay, can we somehow find a clever way to increase the power gain in a way that is better than linear? All right, so let's keep these two observations in mind while I'm proceeding with my presentation. Now, oh, sorry. Yep. Now, let's first address the problem with the space issue. Whenever, as I said, we need to have large spacing between the antenna elements to minimize mutual coupling, and that's not a viable solution in a massive MIMO geometry. What if we go for a compact antenna array or a dense antenna array, in which case the spacing between the antennas is sub-wavelength, okay? And we do that to minimize the antenna array footprint. Now, once we do this, we know that the mutual coupling will be exacerbated. And of course, the natural question is, okay, that's not something we really want, right? Is it? Actually, there is a way to use mutual coupling for our own benefit to improve the performance. So we can turn mutual coupling from a curse into a blessing, all right? And there are lots of papers in the literature that have shown this, you know? Now, this is precisely the ground on which superdirectivity kicks in. We need to go back to 1946 and a paper published by an author called Uskov showed that in theory, an N-phi uniform linear array with n isotropic radiators can achieve a maximum directivity of n squared. And this is achieved with vanishing inter-element spacing. Okay, so if you bring the antennas closer and closer to each other, then your superdirectivity will explode and will, you know, asymptotically become n squared. Remember, before, with a typical design, we can achieve a directivity equal that scales with n. Here, we have a quadratic increase. So that's a substantial enhancement in performance. But that's all in theory, right? In 1946, there was no prototyping of superdirective antenna arrays. And I will explain now why it has taken so long to, you know, to implement superdirective antenna arrays on a massive scale, right? Superdirective antenna arrays have some fundamental challenges. Okay, so the first one is that in order to achieve strong mutual coupling, you need large antenna currents. Okay, so strong antenna currents in turn means that we have high ohmic losses. Okay, high ohmic losses means that the radiation efficiency of superdirective antenna arrays is very low. Okay, so on one hand, we have the very strong directivity, but on the other hand, we have very low radiation efficiency. These two, you know, are conflicting objectives. And also, we have high reactive power, okay? So these fundamental challenges have historically undermined the development of superdirective antenna arrays. There have been works over the past years, but not, you know, there were groups that, you know, published some papers on superdirective antenna arrays, then another group took over, published a few papers, then gave up. So it's some sort of relaying of research efforts. You know, one group does some work and then passes the relay on to the other group, and so on and so forth. My vision here is that we need to sit down and exploit the knowledge we have from the massive MIMO literature over the past 10 years and apply this knowledge on the development of superdirective antenna arrays that actually work, okay? So this is the motivation of today's presentation. Are there any questions? Okay. Now, right. Now, on top of this, let's see let's see what the related work, what kind of related work has been reported in the literature. There are a couple of crude assumptions that research, relevant papers have been making in this space. For instance, they consider very simplistic antenna models to analyze the superdirectivity effect. For instance, they consider isotropic or infinitely small radiators. These, these radiators are okay to investigate from a theoretical perspective, but in practice they don't exist. So the antenna models have very limited practical usability. Okay. Now, the antenna models also overlook the physical dimensions of the individual array elements. And an array element has a radius and it has a width, okay? To begin with, and a length, of course, right? So the by neglecting these physical dimensions, we automatically neglect important physical manifestations that can affect the superdirectivity of antenna arrays. On top of this, they typically neglect the voltage sources driving the array, and I will show later on why this is important to take into account. And they don't consider, they solely and exclusively focus on the array directivity as a figure of merit. Instead, in our work, we take a step further and look at things like achievable rates, radiation efficiency, and so on and so forth. Okay, if you look at the exclusively at array directivity, you lose very valuable information regarding other figures of merit. Okay, now what I'm trying to say is that if we try to maximize directivity only, then we compromise other figures of merit like radiation efficiency. Instead, we could step a little back from maximizing the array directivity in order to get away with sufficient radiation efficiency. So there's a trade-off there that we need to take into account. Okay. Please keep in mind that an antenna array with super high directivity and zero radiation efficiency is not a practical antenna array. Okay, no one will invest into that solution. No academic or no antenna manufacturer. Okay. Now, let me now articulate the contributions of our work. Our work moves away from the state of the art that considers simplistic antenna models. Instead, in our work, we focus on linear dipoles, which are one of the most common type of antennas. And okay, so that's a first contribution. The first contribution is that we consider an array model of dipoles of arbitrary length based on electromagnetic theory. Okay, so we take into account the the length and the radius of the dipoles into our analysis. Then we do take into account the voltage sources driving the array, and the reason we do that is because we want to design an optimal impedance matching network under mutual coupling. Okay. And finally, we do not focus only on array directivity as a figure of merit, but instead we look into the array gain that accounts for the ohmic losses of imperfect radiators. Okay. Is there any question? There is a question. In the case of power, electricity with remotely operated devices, antennas, can you use wireless power transmission? Yes, we can. This is called wireless power and transfer, but we have to take into account that this has limited operating range and also has to abide with very strict electromagnetic compatibility requirements. Okay, you cannot simply transmit 1 watt of energy in open space. You know, there are strict requirements there, but in practice it is possible. Okay. Okay, now we've reached a point that we are ready to introduce our system model, and I'm going to start with the model of the dipole array. So this is a dipole array. Okay, we have n dipoles placed parallel to each other. Each one of them has a radius of rho and a length of L, and we consider the sinusoidal current distribution, okay, given by this form. All right. Later on, I will show that this is a very, very rigorous assumption that we make, and that will be validated by electromagnetic numerical simulations. Okay. Then we can go back to our antenna array textbooks and calculate the total E field under this sinusoidal current distribution assumption given by this expression. Okay. And then, in order to calculate the radiated power, we integrate over the squared of the total E field, and then we end up with this very beautiful equation. Now, I here is the vector containing the antenna currents that excite each antenna element, and Z real is the real, it's a real valued matrix, okay? So we have an expression for the radiated power of this antenna array consisting of linear dipoles. Then we introduce we calculate the loss resistance of the conductors due to the skin effect given by this equation, okay, where this term is the resistance per unit length. These are not U equations, have been used, we have borrowed equations from the literature and of course adapted to the specific model of dipole array, all right? So this is not super new knowledge, but nonetheless it has been modified to fit our model. Now, the total input power is, of course, given by this equation, all right? This is the loss resistance. This is Z real, that, was also used here. And then I can put everything together and have this beautiful equation, all right? So we have the currents, and we have the input impedance matrix. This Z in is the input impedance matrix. So we look at the real value of the input impedance matrix, okay, to calculate the total input power. And then the array gain scale like this, okay. So is the radiated power over the total input power, all right. So it's analogous to this fraction. Any questions so far? Everyone's happy? Okay. Now, the total power, of course, is equal to the total input power, okay, plus the input power to the array, to the antenna array, okay, and can be given, if I put everything together, it can be given like this, okay. Now, the received power, according to the the Friese equation of free space equation is analogous to the total transmitted power times the gain of the array times this very well-known term, lambda over 4pr. R is the distance between the antenna array and the receiver, and eta here is the radiation efficiency, okay, which takes values from 0 to 1.2. At maximum, P in is equal to P total, and eta becomes equal to 1 over 2. All right? And this Zm here are, of course, the impedance matching network. These are for two sources here, but of course, if we have, we have n sources, so this matrix has dimensions n times n. All right. Now, our goal here is to maximize to make the efficiency equal to 1.2, in which case PR is given by this equation. All I'm doing, I'm going back here and set eta equal to 1 over 2, okay? And we want to maximize the received power, okay? Or in other words, we want to maximize the gain by carefully selecting the currents that excite the antenna ports, okay? And of course, we can impose a total power constraint on the transmit power. So P total should be upper bounded by PT. That is a threshold that we select according to the application under consideration. Now, this is a very nice equation to optimize because it's a Rayleigh quotient, okay? It's the ratio of two quadratic form. And we know from fundamental linear algebra that the solution to this generalized Rayleigh quotient problem is given like this. That's very easy you can easily find this in the literature. So what we have is a closed form solution to the optimal current excitation problem. So we can a priori design my currents in order to maximize the antenna array gain, subject to a total power constraint. All right? So that's a very important contribution. And as you can see, this solution has a very tractable form, okay? Depends only on the steering vectors, the transmit power, PT, and Z in, okay? Here and here, the input impedance matrix. All right. Are there any questions? Okay. Now, let's see some numerical results. Okay. Here, I'm plotting the array gain as a function of the number of antennas. So my number of antennas goes from 1 to 25, okay? And I have three curves. The blue curve is the uncoupled model, where we don't consider mutual coupling, and we naively calculate the currents. Okay, this is a solution that has been used in many papers. Oh, there is a question, sorry. Okay, no, sir. All right. And then we have two red curves here. The straight red curve shows the array gain when we use this selection, this optimal current excitation, okay, for a spacing of lambda over 3. And the dashed red curve is whenever the spacing between the antennas is lambda over 2.5. Why I'm plotting two values here, and I'll show later on that lambda over 2.5 gives me is an optimal choice, and I will explain later how this comes. Okay, so I want to showcase here the difference between the two red curves. It's not huge, but it's still visible. And of course, the difference between the red curves and the blue curves is chaotic, okay? No comparison. Now, we also have the radiated power here. The blue curve is agnostic to the number of antennas, so it transmits the same radiated power, whereas the red curve, whenever we go for the optimal design, the radiated power decreases as we increase the number of antennas, okay? And here is the achievable rate in gigabits per second. I'm using the Shannon formula to calculate my, my achievable rate, and we see that there is a substantial difference between the blue curve and the red curves, okay? Remember, this is gigabit per second, so this is approximately 4.5 gigabits per second, and this is 5.5. This is for a bandwidth of 1 gigahertz, okay? Now, I have some more curves when the, here where my point is to try to demonstrate the effect of the dipole length. I want to see how the dipole length affects the performance of super directive antenna arrays. Okay, so the dipole length is on the x-axis here across all graphs, and we can see that long dipoles do yield high array gain with low antenna currents. Okay, but of course there is there is a saturation point around 0.9, after which it doesn't make sense to keep increasing the dipole length. Okay, and again, as you can see, the difference between the red curve and the blue curve is huge. Here the array gain is, I would say, 20, and here the array gain is 37. All right. Looking at the achievable rate, here the achievable rate is approximately 3.6 gigabits per second, and here the achievable rate is 4.5 gigabits per second. So we have managed to increase data rate by 1 gigabit per second by simply going for this kind of solution. Okay. Now, of course, high array gain means that the radiation efficiency is better. Okay, that's what it is. Now, we want to look now at the effect of dipole radius. Okay, remember that the dipoles have length L and a radius rho. Okay, so we look at this, the effect of L, but now I want to look at the effect of rho. So let's see how my results look like. So I keep here increasing by dipole radius. Okay. And we do see a substantial improvement in the array gain, okay? But we also see and substantial increase in the maximum current, and therefore also in the radiated power. So we improve the directivity, but at the same time, we increase the ohmic losses because the currents are going up, and therefore the ohmic losses increases, which in turn means that this increasing the dipole radius will effectively compromise the radiation efficiency. Remember, high currents means high ohmic losses, and high ohmic losses means low radiation efficiency. This is why at the beginning of my presentation, I emphasized the importance of looking at other figures of merit instead of array gain, okay, or directivity. If we look at the directivity only, we see only part of the story, okay? We need to look at other metrics as well, all right? Now, the blue curve it's a no-brainer here. The blue curve just fails to provide an effect, a decent array gain, regardless of the dipole radius. Okay, so you see here in the same with the achievable rate, there is negligible difference as we keep increasing the dipole radius. All right, so super thin dipoles, it's not a good idea. All right, because they suffer from low radiation efficiency. Now, the last thing I want to talk about is I want to showcase that the approximation I made with my sinusoidal current distribution is actually, rigorous. And in order to do so, I introduce a method of moments-based approach. So I'm expressing my electric field like this, okay? And these are the basis functions, all right? And now the way I select the distributions is through a method of moments that are called, and they have to satisfy a system of coupled integral equations called Hallen's equations, which you can solve by the method of moments. So I want to see how my Hallen's equations solution compares to the sinusoidal approach that I used so far. Okay, so these are some numerical results that have been generated from NEC, okay, which is a electromagnetic numerical toolbox. So I have my sinusoidal curve, the blue one. I have the Hallen's integral equations represented by the red circles, and I have the black crosses which represent the NEC solution, what the numerical simulator returns. And we see an excellent match across the length of the dipole. Okay, there is a small mismatch here, which is perfectly expected because we know that the method of moments starts failing for larger dipole lengths. Okay, so this is perfectly expected. Okay, besides, we are not going to be using these long dipoles anyway. Oh, that's a question. Okay. Then we plot the array gain against the radius. We see a perfect match here. All right. And then we plot the array gain as a function of the inter-element distance, okay, normalized by lambda. What we see here is that the array gain is maximized at 0.4 lambda, which is lambda divided by 2.5. This is precisely why I plotted this curve here, this red curve. This is why I plotted lambda over 2.5 or 0.4 times lambda here, because this is the optimal choice of the inter-element distance. And we do see a difference between the naive solution of lambda over 3. Okay, this is because my array gain is maximized at this distance. Okay, now I think I've been talking for nearly 40 minutes. Oh, this is the last graph I have. I have a 2D pattern, okay, with the sinusoidal solution and the Hallen's integral equations. We see a perfect match between these two approaches, and this is a 3D plot. Excuse me, in NEC. As you can see, at the end fire direction of 90 degrees, my solution returns an array gain of nearly 17 dBi, okay, which is a very substantial improvement compared to the state of the art. So let me put everything together and wrap things with my talk up. So the main challenges of superdirectivity is the large antenna currents, the high ohmic losses leading to low radiation efficiency, and a high reactive power. We have managed to address all these fundamental challenges. Okay, and our model is very simple. It does not need tedious numerical simulations, and we were able to achieve a super gain with high radiation efficiency. And this is possible as long as the dipoles are not too short or too thin. Okay, so the antenna dimensions, the radiator dimensions play a crucial role in the performance of the antenna array, and they need to be taken into account. In our future work, we are going to look at how we can evaluate the quality factor, the Q factor of the antenna array, and we would also like to see how the proposed solution behaves in in wider bandwidths, and we also want to find a solution to the reactive power problem. Okay, we have our solution suppresses the reactive power, but I think we can do far better. So this is ongoing work at the moment, and of course we want to offer agility to our solutions, because right now we do achieve substantial directivity, but only at the end-fire direction. In an ideal world, we would like to have a fully beam-steered super directive antenna array that can serve different directions. Okay, not only the end-fire. And I guess that's me for now. If there are any questions, I'm happy to take them. Thank you.
So as for now, there are no questions in the chat. And thank you so much, sir, for enlightening us with your insightful words. Now, let's move on to the next keynote session for the day. We have Professor Stefano Berretti. Stefano Berretti is an associate professor at the Media Integration and Communication Center at the Department of Information Technology of the University of Florence, Italy, since 2011. In April 2017, he got the habilitation as full professor in computer engineering from the Italian Ministry of Education, University and Research. His research interests are in the areas of computer vision, pattern recognition, and multimedia. He has been actively involved with different roles in the organization of several conferences, among which the International Conference of Multimedia, Computing and Systems 1999, ACM Multimedia 2010, and European Conference on Computer Vision 2012. He was the co-chair of the 5th workshop on non-rigid shape analysis and deformable image alignment 2012. In conjunction with ECCV 2012, and also served as program chair and program committee member of several conferences and workshops. He regularly serves as a reviewer for many leading conferences and journals in the areas of computer vision, pattern recognition, and multimedia. Since 2016, he is the information director of the ACM transactions on multimedia communications and applications, and from May 2018, associate editor of the IET Computer Vision Journal. We welcome you, sir, to share your thoughts with us.
Thank you very much for the nice introduction. So let me try to share my screen. Okay, so can you see my screen?
Yes, sir, it is visible.
Oh, okay, thank you very much. So my talk actually is on a very different topic from the previous keynote, because as said during the introduction, my research area is in the domain of basically computer vision, multimedia, and artificial intelligence. So my talk is about 3D face modeling and reconstruction, which is actually a quite problem studied since many years. And here I want to share with you some recent results from our group. In particular, we defined a new model for reconstructing and generating new faces And this model is called sparse and locally coherent morphable model. So let me, first of all, sorry. Sorry, just, okay. Let me, first of all, introduce the idea of the problem of 3D modeling and reconstruction. To this end, I divided here the problem between objects and faces. Indeed, the problem of reconstruction has been studied since a long time. And anyway, there is some difference between general objects and faces. In particular, 3D objects usually show a variable 3D shape and the structure, as we can see on the left for some chairs. Differently, the face instances are, of course, differences because we have a variability in the face, but the structure of the face is the same. So we have the nose, the mouth, and the eyes. The two domains share the same representation in the case of 2D projection, because in that case, the 2D shape changes according to the viewpoint. And instead, another difference is in the fact that, for example, a rigid object like a chair does not change when we consider different instances because the object is rigid. Differently, the face can deform because we can speak, we can show facial expression. So the shape of the face is deformable. And so this is something that we have to take into account when we want to model and reconstruct the face. An interesting solution that has been studied and proposed since 20 years is the so-called morphable model of the face. Here, the idea is that the intuition is that the prior knowledge about a specific class of objects can be useful, can be important in order to solve problems that are otherwise ill-posed. And so the morphable model follows this idea, and the model basically captures the prior knowledge about the face, and this is done by learning from a set of training examples. So 3D morphable models are a general representation for faces, so their goal is not a specific one, but can be used in a variety of different applications. And in particular, since their initial introduction with this work by Blans and Vetter in 1999, now there has been in the last 3-4 years a rediscovering of this approach, of this morphable model, in particular in the context of deep learning. And now we can see that morphable models are used in many solutions for investigating face recognition, facial expression recognition, action unit, and also in face reconstruction and generation. And so here in this figure, you can see a timeline of the evolution of morphable models since this initial proposal by Blans and Vetter through the Basel face model by Paisan et al. And these very recent solutions, most of them based on deep learning. So let me spend some words about this, the idea of the morphable model and the initial solution by Blans and Vetter. Their idea was that of modeling the shape of the face by computing an average model, which is basically the average of a set of training samples, and then to model the deformation of the face by a set of learning deformation components, that are indicated here as CI. So the idea is that this model can be used to generate new face instances, as we can see here on the right. So basically, it is a generative model. The standard approach in order to learn this deformation component is that of using PCA on a set of training examples. In particular, in the approach of Blankenvetter, just 200 neutral phases were used as a training set. So, as you know, the principal component analysis basically provides global analysis of the data. So the idea is that these deformation components basically capture overall deformation of the phase. And so these components both capture variation in different regions of the phase. And this model has obviously some limitations. In particular, as I said, in the training set, there are no facial expressions. So this limits the capability of the model of reproducing facial expressions. And as I said, the PCA is global. And so each component acts on the entire phase. And related to the first problem, in particular to the fact that the facial expressions are not included in the training data, there is the fact that in the training data there is not much diversity between the different phase instances. And of course, the model cannot reproduce something that has not been seen in the training. So there has been some workaround for this. In particular, this morphable model has been subdivided in different regions. So for the eyes, for the nose, and for the mouth. And this way, the authors try to compensate for the fact that PCA provides a global deformation of the face. And so here you can see an example of what I was saying before, and that is the fact that the morphable model can generate different instances of the face. So here you can see, for example, in the first row, a model which is in between and the average model and a prototype. And in the other row, you can see other models that have been generated by modifying the shape and the texture, so the S and T from the average model, and each component represents if the specific regions of the face has been kept untouched, or if that particular region has been deformed in one direction or in the other. And so here you can also see some of the applications proposed in the original formulation of the morphable model. So the idea of reconstructing the 3D geometry of the face given a 2D image, as in the first row. And the other two rows, you can see the possibility to transfer some attributes from a given image to a 3D model, so to render an image with the new properties. So for example, the face in this case of Tom Hanks is changed, so it is more thin or more fat. And in the lower row, you can see some changes in the expression. But you can see here that expressions changes are very limited because, as I said you before, there are no much variation in just very few variations in expression in the training set. And so one problem in using more training models for this morphable model is given by the need for posing these scans in a dense correspondence. Dense correspondence means that each vertex must have the same anatomical reference across all the scans. So for each point, basically each point across all the training scans should represent the same anatomical part of the face. And so in order to obtain this dense correspondence, several solutions have been proposed so far. one popular idea, one popular solution is that of taking a 3D morphable model as a reference template with a known topology, and then apply a 3D morphable model fitting method to the template to the target face. So the fitting try to modify the template to the target face. And so at the end, transfer the template annotation from the average model to the target shape. So this is supposed to establish a point-to-point association, but of course, this method fails in case of large topological differences. So if there are large misalignment between corresponding spatial areas, this prevents effective deformation. And so in addition, you can see that it's like a chicken and egg problem, because we want to have more models in order to train an effective morphable model, but in order to put these training models in correspondence, actually we try to use a morphable model. So in order to alleviate in some way these problems, a workaround that has been used in the literature is that of using a sparse set of facial landmarks. These are detected in relevant regions of the face and are used to initialize the template deformation. So here you can see basically the average model, the template, with some annotating landmarks, and on the left you have predicting landmarks in the target face. So this can be done by separating the expression fitting, and so you have the deformed model and the target one, and the shape fitting. So at the end, some correspondence can be found guided by these landmarks. But of course, this solution is not optimal, because landmark detection is by itself challenging, and in many cases it is also inaccurate. So here I want to introduce you to one first result that we obtain in this work, in this direction, and this is what we call a non-rigid fitting solution, where the idea is that of proposing methods to establish such a dense point-to-point correspondence between 3D models. And the idea is that instead of directly finding the nearest neighbor in the target with respect to the template, our idea is that to obtain this correspondence by an iterative process that is reported. Basically, the main operations are reported here. So suppose to have a point of the template, and you want to find in the target face the best corresponding points, so the points to be associated with the template vertex. So to this end, we have this iterative procedure where we initially perform the rigid alignment by using the iterative closest point algorithm. And so this is something that find an initial correspondence between points, and then we perform point-to-point correspondence estimation with a method that I will show you in a few moments. And then we perform the model deformation, and then we iterate this process till the convergence. So basically, we iterate the ICP, the point-to-point correspondence, and the model deformation. And so at the end, we are able to transfer the semantic labeling in the average model to the target one. So the process at the beginning is initialized by zero centering the 3D shapes, and using a initial step of the ICP algorithm in order to find an initial correspondence between points. And in this phase, the nose tip is also used in order to to find an initial alignment between the two models. Then we have this procedure where the main interesting idea is given by this mean point association. The idea is actually simple, but resulted effective in practice if we consider to have this point Sj in the template model. Instead of associating this point directly to one point, usually the nearest neighbor one in the target shape, actually we consider a region of target vertices. Basically, these are the points in the target shape that belong to the Voronoi region. So this means that these points all have the Sj points as the closest one. And then we compute the mean point Tj in this region. And so at the end, the correspondence is found between the template vertex Sj with one of these mean points in the regions that are close to Sj. To do this, we also use two thresholds, a local threshold, this tau j, and the global threshold is tau g, one for the specific region as reported here in the figure, and one instead for the overall shape. These are based on distances and standard deviation of the distance in the region and in the overall phase. And so this is the step that find the correspondence, and then we have this mean point association. So we have this step of guided by the mean point association. We have this step of deformation that uses the components of a morphable model. So the idea here is that of solve this minimization problem, where we found the difference between the target shape with the point associated to the average shape S, and C alpha is the multiplication between the deformation components of the morphable model and the coefficient alpha, which are indeed the unknown of this minimization problem. So we want to find the coefficient that best deform the average model in order to match with the target. And so this is a regularized least square problem. Here we have a regularization terms that also account for the amplitude of the deformation components. And this actually can be solved in closed form. So with this process, we are able to find the coefficients alpha that best deform the model on the target. And so, as I said before, this process is iterated. So the steps of registration, point correspondence, and minimization are iterated. Usually 3, 4, from 2 to 4 iterations are sufficient in order to find a good correspondence. And here you can see basically the pipeline. Here you have the template, so the average model. The first step is that of rigid alignment. So here you can see the target model is this one. So here you can see the point clouds that are aligned using ICP, using rigid alignment. And then in the middle of the figure, you can see the different iterations of the process. And here you can see how the deformation of the template moves towards the target. And so here you have the final deformation of the template, which is in a very good correspondence with the target shape. And in the upper part of the figure, you can see that the non-rigid fitting is capable to be robust to noise, as can be seen here in the border of the face or in the mouth region, and also to invalid regions, as can be represented by the hair or by the region again of the mouth. And so in the lower part of the figure, you can also see the how the error, the point-to-point error between the model and the target reduces during the different iterations. Because you see the blue regions basically correspond to a very small error compared to the red regions when say the error is high. So this is our NRF deformation. And with this model, we are able to solve, or at least to effectively address several critical situations. In particular, we proved that this model can work in a good way in the case of heterogeneous scans. So we are able to apply this fitting procedure to high resolution and very high definition scans, but also to scans that have been acquired with low resolution 3D scans. So it is a method which is robust across different data. Our method is capable to obtain a dense correspondence with thousands of 3D faces, and we are able to keep into account of expressions. And another interesting property is that our method does not require landmarks for initialization. So it is a completely automatic method to fit two 3D faces in a non-rigid way. So accounting also for expression, as I say. And so here you can see some examples of this fitting. So here you have the result of our fitting, and here you have the ground truth with the corresponding error maps. And again, this method, as I said, showed to be effective in order to also perform landmark detection, because if we suppose to annotate some landmarks in the reference model, in the template, when after we fit the model on the target shape, actually we can transfer the landmarks to the target. So here you can see in red the ground truth landmarks of the face, and in green you can see the transferred landmarks from the template. So you can see that across three different datasets, 3D datasets with very different resolution, the method is still effective. In particular, you can see that the face warehouse is acquired with low resolution cameras like Kinect, and so this our method is can be applied also in this case with good results. In the last column, you can see basically the model, the template model, the formed model, when it is remapped with the corresponding vertices in the target. So we can look to these shapes as the result of the fitting when we consider the target points in order to show the 3D rendering of the face. And again, here we have a comparison in the landmark detection between our model and our solution. So here we have the fitting result with the detecting landmarks for our shape with respect to the ground truth. And in the first two columns, you can see the result obtained using the non-rigid rigid ICP, which is more or less the state of the art, or one of the methods using the state of the art, and the result using the nearest neighbor solution. So you can appreciate that with our model, we are capable to have a more precise localization of the landmarks, and we can also cope with variations of the topology and with expressions in the target face. So this is one first result of our solution, but now it is also interesting to address the way we learned the deformation components, which is another contribution. And as I said at the beginning, actually deforming the morphable model to find the correspondence is like a chicken and egg problem, because of course the morphable model is something that we learn from models that are syndense correspondence. And so about the learning, the problem of learning the deformation components, as I said, there are several approaches in the literature. The basic one, as we illustrated in the case of the Blansen-Vettel model, is given by the principal component analysis. But then in the years, there have other proposals. In particular, for example, some authors proposed to use a Gaussian process in order to learn the components, a mixture of Gaussian or additional learning, or again, wavelets and sparse PCA, or deep networks in the recent years. But all these works are accumulated by the fact that in all of them, each 3D phase is considered as a training sample. And so, also as a consequence of this, all capture global correlations in the data. And the amount of training data also is strongly influences the 3D morphable model learning. So basically, since this method, the learning is based on the number of instances, these numbers basically provides a bound, a limitation on the learning capability of the model. So this is just a summary of what usually the methods done. They consider a set of training examples, so n phases, Fi, each with m vertices with 3 coordinates. So basically, we have these column vectors here. Each vector corresponds to a 3D phase. We have n of these vectors. So we have a training matrix. Then we can compute PCA on the training data. And so we can obtain a set key of deformation components, of principal components of the phase that are used for deformation. This is the done by PCA, but it is usually the approach proposed also by the other methods. Actually, we try to follow a different way to obtain the deformation components. The intuition is guided by the musculoskeletal structure of the human face. The idea is that points in the face do not move in a completely independent way. I mean that if we consider a vertex, neighboring vertices move according using consistent patterns. This is quite intuitive and can be seen here in the figure. So learning primary directions of deformation, and the idea is that of learning this primary direction of deformation and approximate the motion in local regions by expanding these motion directions. So mathematically, this is formulated in this way. We consider the main switch in the way we use the training data is that we consider each vertex as an independent sample. So in this way, we have 3M vertex component that represent the variation of a coordinate across the scans. So we look to the individual vertices rather than to the interface. And so we are capable to estimate key primary direction, di, by solving a regularized elastic net regression, which is this problem represented here. And so where one of the unknown are the directions. And then we can also, once the directions are found, we can learn to reconstruct the input data given the set of primary direction using the lasso algorithm. And so we can, at this point, compute the sparse coefficients Ci, which are used as our deformation component. So basically, these coefficients indicates how the how the neighboring of a point should move according to the particular direction. This problem is also, we have also two constraints, one to force the sparsity of the coefficient, and the other constraint is in order to encourage the grouping effect between near points. And so here, okay, I report the same equation, but here it is interesting to look to the idea. So basically the training matrix is the transpose of what we have seen before, because now we have n rows, and each row account for the way a specific vertex of the face does change across all the scans. So we have 3m columns, and we apply this sparse and locally coherent solution in order to find this primary direction of the deformation and the associated expansion coefficients, which are actually our deformation components. So these are sparse. This means that many values are 0, and just the components that are that represent points that move according to that direction are not 0. And so you can see here on the right that in this case the components are very localized. And so it is interesting that we obtain these decorrelated motions of the regions. And so we can have more deformation, and the deformation are sparse and localized, that we can see here on the right. So we can have components that are related to the identity. So for example, the shape of the nose or some part of the face. And there are also components that control the expressions, like the region of the eyebrow or the side part of the mouth. And so it's also interesting that we have a reduced dependency from the number of the training scans, because actually we focus on the vertices. So these are 3m, and this is independent from the number of face scans. And so we have a better capability to generalize to unseen identities. So here you can see some results where we compare our solution with the PCA and the Neural 3D MM, which is a recent deep learning morphable model solution. This is obtained on the COMA dataset, which is a dataset with 3D animation and strong facial expression. So you can see here that even in the case of very strong expressions, our solution is capable to obtain quite low reconstruction error in the region, for example, here in the mouth, where there is a large deformation with respect to other solutions. So going to the conclusion of my talk, I also reported here some results of our method. In this slide, we investigate the effect of the non-rigid fitting approach, so the method for fitting the morphable model to the target shape. And so here we can you can see that we associated our fitting method, the NRF, with the different solution for learning the components of the morphable model. And we observed that indeed this NRF is useful to improve with respect to the nearest neighbor solution, which is here represented by the green plot. And the improvement is also quite evident with respect, for example, to some other solution like the CPD, which is the coherent point drift, which is a non-rigid deformation method. So in this case, we report the error just in correspondence with the facial landmarks of the face. So the comparison is performed on the landmarks of the face, which are used as reference points, because in that point we know the ground truth, and so we can compute the error. And we performed this for 3 different datasets. So you can see that actually the NRF is robust, performing good result across different datasets. In particular here, it is interesting to see that the results are very good also compared to other solutions for a dataset of very low resolution data, which is the phase warehouse that, as I said, you is captured by using a Kinect sensor. Then we investigated the effect of the sparse and locally coherent deformation components of our method. And so here you can see that one interesting property of our method is that we can have more components than our solution of other solutions, because we are not bounded by the number of the training examples. And we can see that the reconstruction error performed on the COMA dataset is clearly below the state of the art. So PCA, other solutions in the literature, like the dictionary learning, the COMA solution, which is based on encoder-decoder network, and also the neural 3D-MM, which is also an encoder-decoder morphable model. So here in the central plot, you can see that if we consider, for example, an error of 1 millimeter, in our case, 92% of the vertices are relocated, are mapped, are reconstructed with an error of below of this threshold. And you can see that we are clearly, our performance are clearly better than other methods in literature. And in particular, it is very, very interesting the fact that we are also capable to overcome, to surpass by a large factor morphable model, which are based on deep learning solution. And again, here on the right, we show that if the training set is very limited, so for example, we have just this small number of training scans, the effect of our solution is even more remarkable, because with respect to the case of, for example, the neural 3D MM, this means that our method is capable of learning consistent representation, even in the case the training set is small. We investigated also the behavior in the case of expression. So in the COMA, there are 12 different expressions. So in the horizontal axis here, you can see the different expressions. And in the vertical axis, you have the error, again, compared to the PCA and the dictionary learning. And again, we see that the error in our case is considerably lower. In the case that unseen expressions are reconstructed and also unseen identities. So in particular, our method is very good also to reconstruct identities that are known, and also expressions that are not included in the training set. So to conclude, I want just to show you some more applications. The first one is related again to the possibility to use our approach to locate, to detect landmarks of the face. And it is also interesting that with our method, we can control the local deformation of the face, and we can also control the amplitude of the deformation regions. So we can have very localized regions, or we can have larger areas. So this opens the way to a set of applications. For example, we can control here the size and the shape of the nose. If we start from the average model in the middle, we can have a thinner nose or more important nose, just acting on a specific deformation components of the face. We can act on the upper lip, for example, in this second row, and we can act on the two sides of the mouth. Of course, this can be good, for example, for computer graphics applications. And again, our solution can be also very good for action units that are very important to analyze facial expressions, and also for example, medical application in a situation where, for example, you want to investigate how the face is capable to deform, for example, for people that recover or are making a rehabilitation after some stroke, or maybe they are affected by some diseases like Parkinson's or Alzheimer. It is important to be able to evaluate how the face is capable to deform. And again, we can control here on the right the deformation of different parts of the face. And so I am at the end, I think. So here the last slide is to summarize what I try to show to you. So basically, I presented a new way for learning a statistical model of a 3D face. And in doing so, there are two main challenges. The first one is that of establishing dense correspondence between heterogeneous 3D faces. And the second one is that of learning generalized deformation component. So our solution, which is based on learning sparse and locally coherent components, proved to be effective together with the use of non-rigid fitting. We show that these two solutions combined together are capable to surpass, to obtain superior performance with respect to the state of the art. And another interesting observation is that using traditional machine learning and classic machine learning and computer vision methods, we are able to obtain superior performance with respect to deep learning solutions. And we obtain a remarkable improvement with respect to the existing solution, in particular when the target shape deviate from the training data. So that's all. Thank you very much for your attention. You can find more information on these methods in this recent PAMI paper, accepted paper. So it is online since June of the last year. And of course, you can contact me at this email address if you have more questions of curiosity about our work. So thank you very much for your attention. And if there are any questions, I am happy to try to answer to you. Thank you very much. So
Thank you very much, sir. No, sir, there are no questions as for now. Thank you so much, sir, for sharing a reflective knowledge with us. Moving forward towards the last keynote session for the day, we have Professor Anu Agarwal. Anuji Agarwal is a professor in Department of Operational Research, University of Delhi, with more than 20 years of teaching and research experience. She obtained a PhD, MPhil, and MSc degrees in operational research from the University of Delhi. Her key research interests include mathematical modeling and optimization in consumer buying behavior, innovation diffusion modeling, electronic commerce, multi-criteria decision-making techniques, reliability growth modeling for software systems, and applications of soft computing techniques. She is an active researcher with more than 100 research publications in international peer-reviewed journals, books, chapters, and international conference proceedings. She has guided more than 20 MPhil and 5 PhD students, served as technical chair, co-chair for a number of international conferences, undertaken a number of research projects funded by government agencies as PI and co-PI, delivered invited talks at international conferences, and served as resource person at UGC-funded refresher courses and faculty development programs. She has been awarded Young Researcher Award for applications of soft computing techniques and software reliability awarded at the 4th International Conference on Quality, Reliability, and Incoform Technology in year 2009. She has served as governing body member of a number of colleges, member of the UGC Expert Committee for Evaluation of the Performance of Colleges or Universities, member of several undergraduate and postgraduate committees, research committee in a number of state and central universities. Ma'am, it's an honor for me to invite you on stage for sharing your knowledgeable words.
Thank you, Ms. Divanshi, for saying kind words about me. Before I start the session, I would like to convey my sincere thanks to the organizers of this conference, Dr. Samir Anand, Dr. Ajay Jaiswal, Dr. Deepak, and Dr. Ashish for giving me the opportunity to connect with the research scholars and the faculty members, as well as to share my research interests with all of you. Once again, thank you so much. And today I'm going to speak on electronic word of mouth in hospitality. Let me share my knowledge for my screen first. I hope the screen is visible to everyone.
Yes, it is visible, ma'am.
Thank you so much. So today my session is about electronic word of mouth in hospitality. Though before I start with the session, I just want to say, like, whatever we are discussing, that is definitely relevant to, to the online markets. But because I'll be discussing two case studies, real life applications related to the hotel industry, so that's why I've named my session as electronic word of mouth in hospitality. So the plan of the talk is I'll be touching upon three key points. First, what is meant by electronic word of mouth, and then what is relevance in the online markets, and third, I'll be taking those two real life applications where the concept of electronic word of mouth has been applied for strategic decision making. So before we go into the detail, what is meant by electronic word of mouth, we have to go a little bit back, and we have to start with the concept of that what is meant by word of mouth. So word of mouth is basically interpersonal communication between individuals or the group or the communities. And if we talk about the history of word of mouth, and it is as old as the history of humankind. This is how the knowledge or the information has been transferred from one generation to another generation over the ages. And if we talk in the context of marketing, then this is the word of mouth is basically the interpersonal communications channels. It acts as interpersonal communication between the individuals, and this is how people come to know, they become aware about a new product or a service or an idea, or they get to know about the performance of the product or the service. Now, earlier when there was no internet, the businesses were offline, and then we used to talk about the word of mouth based marketing. But now when the internet has taken the entire society by storm, and the businesses have become digitalized, then the concept of word of mouth has transferred from word of mouth to electronic word of mouth. If we talk in terms of online markets, then electronic word of mouth are basically the comments or the statements which are made by the potential customers or by the individuals or by the existing users or the past users about a product or a service, and over the internet, so that others, individuals or the organization can see. Basically, this is how people share their feelings or their assessment about a product. And because it's available online, so the word of mouth, which was there for the offline market, now it has taken the form of electronic word of mouth. If we talk about the e-commerce portals, the way we are shopping online, then these portals, whether it is Amazon or Flipkart or booking.com or tripadvisor.com, they though they provide the facility of buying and selling the products, but yes, they also provide the facility where people can share their feedback, can share their experience in terms of some sentences which are known as e-worm text, or in form of certain ratings ratings on a scale of 1 to 5 or rating on the scale of 1 to 10 about the product or about the comments of others users. When we study the role of EWOM in the online market, it's very important to understand what are the key characteristics related with these EWOM. Those characteristics can be textual in nature, means related to the text, or they can be numerical in nature. Like, for example, if we talk about the textual characteristics, then they can be, the level of understanding, the level of comprehensibility of the text, or the length of the text, or it can be, the kind of emotion conveyed by the text. And if we talk about the numerical aspects of these EWOM, then it can be in form of the ratings, or it can be in the form of that how many comments have been posted online. So broadly speaking, though number of characteristics of these EWOM have been discussed in the literature, but few which have been discussed very widely. They are related to the helpfulness of the comments. They are related to the volume of the comments. Volume, helpfulness means that how much people find, that comment helpful, which help them to making their final decisions, whether to book a hotel or no, whether to buy a product or no, whether to, what knowledge they are getting by reading that comment. And then volume is like, the number of comments which have been written about a product or a service online. Then the ratings are basically the Likert type of, the ratings on the scale of 1 to 5 is a basically Likert type of scale, which people share to express their opinion about the performance of a product or a service, where 1 being the worst and 5 being if the rating is on the scale of 1 to 5, then 1 basically correspond to the worst performance and 5 correspond to the best performance, or 1 maybe the worst experience and 5 can be the very satisfying experience. Then the other characteristics which have been discussed in the literature, they are related to the length of the WOM, means how many words or characters have been included in that text piece, or that is the length. And then the sentiment is the kind of emotion which is portrayed or which is conveyed by the text. It can be positive, it can be negative, it can be neutral. And then the readability is the comprehensibility level of the EWOM. Basically, because in this small session I can touch upon though many characteristics have been discussed in the literature, depending upon the polarity or the subjectivity of the text, or the number of difficult words, number of wrongly or correctly spelled words, but I'll be touching upon only the major ones. So this is the description of those different attributes or the characteristics which I discussed in the previous slide. That what is meant by the volume, the ratings, the readability. Yes, readability is it's a level of comprehensibility of the text, or it basically shows how easy or difficult it is to understand the meaning of the text, how easy it is to comprehend the text. And in the literature, number of measures are there which basically shows the readability level of the text. But what I'll be using, because later on I'll be talking about 2 case studies. So one, the readability measure which I'll be using, that is FKGL measure, and is based upon the number of words in the text, number of sentences in the text, and number of syllables in the text. There are different measures which depend upon the different attributes. Those attributes may be the number of difficult words, number of sentences, number of syllables, number of polysyllables, like that. But what I am using, that is based upon number of words, number of sentences, and number of syllables in the text. The length, EWOM length, basically when we are trying to know how many words or how many characters have been used by the reviewer, the person who has written the comment, that basically shows the length of the EWOM. And why it is important to study that what is the length of the EWOM, because generally it has been seen that longer EVOM basically includes more information or more details about the product about which they are being written. And similarly, it has been seen that usually when people are dissatisfied, then they tend to write longer EVOM. And now the last, the characteristic is the EVOM sentiment. It basically shows the tone of the emotions presented by the text, piece of the text. The tone may be positive, it may be negative, or it may be neutral. It's like, positive, like if it is about a product, it may be like, it may include the recommendation about buying a product. If it is negative, then it may, discourage people to buy something or book a hotel. Or if it is neutral, like, it just includes certain plain comments without recommendation whether to buy or not to buy. So again, to judge that what is the sentiment of a piece of text, again, a number of techniques and tools are there, but based upon natural language processing. But what we are using, that is based upon naive Bayes technique. And there are many other measures, just not naive Bayes. People may use subjectivity, polarity to judge the EVOM sentiment, the sentiment which is shown by a piece of text. Sometimes the ratings also, they help in understanding the emotions of because if people are giving higher ratings, then it also shows that how much, happy, the level of happiness or the level of experience they are having with the product. Now, with that brief background about, what is meant by EVOM and what are the key characteristics associated with that EVOM, now we are talking about what is the importance of these electronic word of mouth in online markets. Now, if we see, because I'll be discussing more in the context of marketing, so I'll be discussing its relevance as from customer side and then from the marketer side. Now, if I read a piece of text which has been posted by other customers or other users online, then basically that helps me to, to make my mind, to make the final, if I'm reading it to, to assess how good the product is, and then I have to take certain decision about the buying or purchasing the product, then basically by reading that EVOM, I will be able to judge, how happy other users are about the product, and it basically helps in making my own mind that whether should I go ahead with the buying decision or should I, stop with whether should I abort the idea of buying the product. Then it also helps in understanding the performance assessment of the product, means quality assessment of the product. It also helps in, maybe it basically helps in attitude formation. Attitude formation means, how much motivated I feel to buy or own something once I read that piece of text. People may feel motivated to buy the things, people may get demotivated after reading the text. So from the customer perspective, EVOM basically helps them in making their mind, in making their attitude about a product or a service, and that it also helps them in better understanding of the quality of the product. Now, if we talk that what role these electronic word of mouth, which are present in the form of text on the internet or over different websites, how it helps a marketer or a business firm, then, basically people may write positive comments, people may write negative comments about a product or service, and same is being conveyed to the customers. But as a marketer, those, by reading those comments or by analyzing those comments, the manager is able to understand, view of the people about their product, their experience, that how happy the people are after using the product or how dissatisfied they are after having that product. It basically helps them to understand the key aspect related to the product where the people are happy, and the other aspects where people might have certain complaints. So basically, if I talk, the role of, electronic word of mouth from the management point of view, then electronic word of mouth basically helps them to understand their strengths as well as their weaknesses. Strengths are like where they can build up, and weaknesses where they need to make the improvements so that they can get over with they can come over the complaints of the customers. So this is how the study of EVOM basically helping both the parties, the customers as well as the managers. Now this is a brief background about the EVOM and what how they can be used by the customer and the marketer for making the online markets a more friendly place to shop. Now I'll be taking up I'll be discussing two case studies related to the hospitality sectors to illustrate that how EVOM is helping in better understanding of the customer behavior as well as the management side. So first, my case study is about that how electronic word of mouth can help in to judge that how a hotel, because I'm talking in the context of hospitality sector. I have picked up as a just illustration purpose. I have picked up hospitality sector. So first, my case study is about that how EVOM help in judging that how a hotel is performing, how happy people are after staying in that hotel, and their satisfaction level, their experiences. Now, when we talk about that before we go into that how EVOM can help in that, if we see in the literature, people have used regression techniques, people have used some qualitative survey-based methods to to judge that that how people, how much happy they are after visiting a hotel or after staying in a hotel. But what we are will be discussing that how the comments which are available online, they can help in analyzing or understanding the experience of the guest. This is the research framework. This is how we are going to implement that. First, we are going to collect the data which is available on, because these EVOMs are available on the different online travel agencies websites like TripAdvisor or Booking.com or Yatra.com or MakeMyTrip.com. So first step is to collect the data from by using some web crawler from these OTA website. Then we have used Python program, or you may use some other tool. Then by using Python program, we extract the features related to EVOM. The features what we have used, they are related to the length of the EVOM, readability of the EVOM, and the sentiment of the EVOM. They are the three features which are related to the text. Another 5 features we have used, they are related to the ratings which people have given to the different service aspects related to the hospitality. And those 5 service aspects are related to the room service, room related to the service, third is cleanliness, fourth is location, and the value. All these 3 features related to the EVOM data and the 5 features related to the ratings what people have given to the different aspects of the hotel, they have been fetched from the EVOM. We have the data what we have extracted from. We have extracted data from TripAdvisor.com. So these 3 plus 5, 8 features have been extracted from that data set. Now we use some regression-based statistical techniques, and then we finally use machine learning techniques to understand first that by using these 8 features, that how we can judge, we can know that this customer is happy or not happy. And then we also try to find out that which features have greater role to play in determining the experience level of the customers. This is how we are, and this is all being done on the basis of features which have been extracted from the EVOM data, which is available on the TripAdvisor.com. Now, it is a step-by-step methodology we have used. The first step was to extract the data we have extracted data from tripadvisor.com, and there are considerable number of it's more as 2,25,582 EVOM, but we have extracted from the tripadvisor.com. And once this data was extracted, then it was from this data 9 features, where 8 features act as the independent variable, and the 9th feature act as the dependent variable, because we are trying to understand the experience of the customer by using, first step is to understand the experience level of the customers through the regression modeling. Then we are also applying the machine learning technique. Okay, so for the regression modeling, we have 8 independent variables and 1 dependent variables. Those 8 independent variables, out of these 8 independent variables, 3 variables are related to the EVOM text, which are the length, readability, and the sentiment, and 5 are related to the aspect ratings, what users have given to the different aspects, different quality attributes of the hotel, and their ratings on the scale of 1 to 5. And there is a one attribute again which we have extracted from this EVOM data only, and that is act as the dependent variable, and which is the overall hotel ratings. Means, again, these are the scale of 1 to 5, and basically this have been given by the users or the guest to the hotel, depending upon their experience while staying in the hotel. These are if you see the table 1, the table 1 basically shows that how many features and the description. Total, 9 features, out of which 8 are independent and 1 is the dependent. They have been included in the model building, and the table 1 shows the gives a brief description about these 9 features, 8 independent and plus 1 dependent. And once the features have been extracted, next is to build the statistical models. We have used incremental type of regression modeling. In why, first regression model will help us to relate the independent variables to dependent variables. It will help us to identify that which variables have significant impact on the dependent variable. Third, by doing the incremental modeling, we'll be able to see that how, when we are increasing the number of independent variables in the model, how the goodness of fit of these regression modeling is changing. So for that purpose, to study, to meet, or to analyze from that how the review text helps in determining the satisfaction levels of the customers, and which aspects are more important in comparison to other. We have made the stepwise regression technique. For that, we have built 7 models. You can see them, they are numbered as 1, 2, 3, 4, 5, 6, 7. And if you can see that in all the 7 models, the dependent variable is same, which is the hotel rating, but there is a difference in the number of independent variables. In the first model, there are 2 independent variables. In the second model, there are 3 independent variables. And when we move from first to second to third, we are introducing 1 additional independent variable to see that how addition of 1 more variable is affecting the goodness of fit of the model. Now we are going to, once the model has been built, now we are going to estimate these models, 7 models, on the data set what we have extracted, and the feature what we have extracted from the data. Now once the model has been built, now we move to the prediction modeling. For the prediction purpose, again, for the prediction purpose means that how the same set of 8 features can help in predicting whether the people are happy or not, whether the people are satisfied or no. We use machine learning based techniques. For that, we build 3 prediction models. First prediction model is based upon the features which are related only to the EVOM text. Second prediction model is based upon the features which are related to the hotel aspect ratings, and the third prediction model, which is based upon the 3 EVOM features as well as 5 hotel aspect ratings. So it combines all the 8 features. Now, this is something which is very interesting to see, that basically table 2 shows the data what we have extracted, the descriptive statistics, because if you see that it gives about the mean, standard deviation, mean value and max value about the different features. In all, there were 9 features which have been extracted, out of which one is a dependent variable and others are the independent variables, and these features have been extracted by on data which consists of more than 2 lakhs of EVOM text. Now, if you now by using this data, we run the regression model, that is the first step, and we estimate the different the regression coefficients corresponding to the different variables. Now, if you can see that basically when we estimate the regression models on this data set of more than 2 lakhs EVOM, then we are able to estimate the coefficients. We also check for their significance at 1% level. So what if you see the table number 3, then table number 3, you can see that it basically helps us to understand that which out of those 8 independent variables, which variable are having significant impact on the customer experience. Few may have positive impact, means higher is the value, higher is the customer experience. Few may have the negative impact, means higher is the value, lower is the customer experience, means more dissatisfied they are with the customer, with the hotel performance. So by checking their level of significance, we can also establish whether these coefficients are significant or no. Here, if you see the table number 3, you can see all the regression coefficients are significant at 1% level of significance, and few have positive association with the dependent variables, whereas few have negative association with the dependent variable. Especially if you see the EVOM length. EVOM length has a negative regression coefficient. Negative regression coefficient means more is the length of the text, less is the customer's experience, means more dissatisfied they are with the hotel. It means as I said in the early, that usually it has been reported in the literature that people who are dissatisfied with the product or the service, they tend to write lengthier reviews. So you can see it that length has a negative association with the hotel ratings. Whereas if you see the sentiment index, means more is the value of the sentiment, more is the value of sentiment, means more positive is the sentiment. Then higher is the hotel ratings. Sentiment index has a positive association with the hotel rating. Similarly, the readability has a positive association with the hotel ratings, means more readable a text is, people tend, more happy people are about the hotel. And similarly, if you see about the association between the 5 aspect ratings and the hotel performance, again they have, you can see it, they have a positive association with the hotel ratings, means they are having the that higher is the rating given by the individuals to different, to the different quality aspects of the hotel. Higher is their experience level, more satisfied they are with respect to the hotel performance. Now, but by regression modeling, we are able to see that which attribute has a positive association and which attribute has a negative association with the hotel performance. But we also can see the degree of their influence, the degree of their association. Few out of these 8 independent variables, few attributes have greater impact on the level of on the hotel performance in comparison to others. Usually the thing is then more is the magnitude of the regression coefficient, greater is its degree of influence on the dependent variable. So this is what we get by doing such type of analysis. Basically, it helps to understand that which attribute or which aspect has a greater impact on the customer experience. So when a hotel manager is trying to build up his brand, wants to enhance the experience of the customer, they know where to act first, which aspect has more importance for the customer. So when they are trying to from their brand building, so this is where they have to attack, this is where they have to work upon. Now we go for now we apply machine learning techniques again to see that how these features related to the text, features related to the hotel aspect quality attributes, how they impact or how they help in predicting the experiences of the customer. As I said earlier, we have built three prediction model, one entirely based upon EVOM textual features, second which is entirely built upon hotel aspect ratings, and the third which takes into consideration all the 8 features. Again, you can, and for the this prediction purpose, 5 techniques have been used, including random forest, artificial neural networks, naive Bayes, sport vector machines, and k-nearest neighbor. Now, if you see from the modeling perspective, then you can see that where we have combined all the features, the accuracy is higher, the precision is more, F measure is higher, and the recall value is also the highest. So it shows that when we have taken into considerations all the features related to the text as well as to the rating which people have given to the different service aspects of the hotel, then those prediction models with the higher accuracy are able to predict that how well their experience of the people have been, or how well the hotel is doing as per the customer feedback. And when we see these, when we compare these 5 classifiers, then we can see that random forest performs best in comparison to other. But if I see from the hospitality point of view, then I can see that when a manager is trying to analyze that view or the opinion which have been expressed in form of the rating and in the form of the form of text, then it's important that he considers the rating which he has given to the service attributes as well as the content of the text. And when we we use the same tools to check the relative importance to the different these features, then you can see that room has got the highest importance, followed by the service, then the sentiment index, readability, and least is the EVOM level. Now, when we are trying to, this is what we have achieved through, this is what we have calculated by using machine learning tools. But same, if you compare these results with the result what we have got by building a regression model, then same type of hierarchy is also there. As per the regression models also, room is the most important attribute. It has got the highest regression coefficient, followed by the service, followed by the sentiment index. So basically it helps in the manager that when he wants to enhance the experience of its guest, then room is the first point where he has to work upon. When we talk about the room, we are referring to the room amenities. We are talking about the bed. We are talking about the bathroom, the cleanliness of the bathroom. We are talking about the room size. This is what we are referring. So this is where this is the foremost area where the hotel hospitality people need to work upon. Then the services. Services include the staff. Services include the different amenities which are there in the hotel, like the Wi-Fi or gym facility like that. So this is the next next most determining factor or the variable with respect to the hotel performance. So, and the other things follow. sentiment index, that what is the kind of emotion which is expressed by the people, how much understandable the text is, how much comprehensible the text is, then the location of the hotel, and value, cleanness, and the e-warm level. So basically, by doing the regression modeling and by getting the same type of conclusions from the machine learning, what we can see that we are able to verify the result what we have obtained from the regression modeling, and then what we have obtained through the machine learning techniques. Secondly, it helps to understand which are the most prominent key areas where the hospitality people need to work to enhance the customer experience. This is one case study what I have included here, that how the e-home text help in the managerial level of decision making, in identifying that which attributes are more important for the customers and which attributes are like where the marketer need to put maximum attention. Now, the second case study what I'm including in today's session is more related about the reviewer, means the individual who is giving the comments, who is posting, who is sharing the feedback in forms of the comment. Usually what happens, when as a user I visit a website and read the comments which have been given by others, then it has been observed in real life that people look for trustworthy reviews, or the reviews which are coming from trustworthy reviewers. So now the marketer, because they know that people basically believe, or they like to read those reviews which are coming from trustworthy reviewers, or the reviews which are perceived to be trustworthy or credible by the readers. So what they do, that whoever is posting the comments, they try to rank those comments in terms of the credibility or the efficiency of the or the trustworthiness of the individuals who are writing those reviews, so that people get genuine advice and they are convinced that whatever information they are reading, that is that is genuine, they are not fake. So it's basically if I talk from the customer perspective, they want that the reviews whatever they are reading, they should be credible, they should not be fake. If I talk about from the marketer perspective, then marketer also need to identify that the whatever comments or the reviews are being posted by the users, they are not coming from the fake users, they are coming from the genuine reviewers, or they are coming from the some some credible reviewers. So now what happens, that usually nowadays if you visit the site of booking.com or tripadvisor.com, recently last few years they have got this trend now, that they have been assigning some sort of badges, or they are their contribution recognizing their contribution levels of the people who are writing reviews for them, not for them who are writing reviews online on their website, because they want that people should read the credible reviews so that it helps them in making the genuine purchasing decisions. So in the TripAdvisor, they have got the practice that they assign certain labels to the reviewers. Those labels are like reviewers, contributor, top contributor, like that. They are assigning so that people, those who are reading, the users who are reading, the prospective customers who are reading, that by looking at the badge which TripAdvisor has given to those reviewers, they are convinced the review which has been written, that is genuine in nature, and they can go by its advice. So here we will be talking that how the comments which have been written by the individuals, they can be used to identify which reviewers are trustworthy, which reviewers are efficient, so that the reviews which have been written by the trustworthy reviewers or the credible reviewers or the efficient reviewers, they can be shown to the prospect customers first. It basically helps in the ranking of the reviews on this website, so that people are served the genuine reviews in the beginning only. So here I'll be talking that how reviewer efficiency may be measured or may be estimated by using the text of the comments what they have given online. So before we go into that, how E1 helps in understanding the efficiency of the different reviewers, we need to define what is meant by reviewer efficiency. So efficiency is basically, it's a very interdisciplinary concept, and efficiency is basically a concept which is related to that basically shows the productivity of individuals. It may be the productivity of certain campaigns or certain activity or some manufacturing unit. Basically shows that how the resources, whenever any activity is undertaken, definitely certain resources are consumed and certain outputs are there. So basically efficiency helps in assessment that how well the resources are being used by by taking a ratio of the inputs and the outputs. This is basically a broadly speaking, the concept of efficiency is there. It's an interdisciplinary concept. In marketing, people talk about the efficiency of the advertisement campaigns, efficiency of the products, and efficiency of the production units, efficiency of the different marketing campaigns, efficiency of the different promotional campaigns, like that. And basically it's a concept which basically combines that how much output is obtained by spending a number of resources. Now when I talk about the concept of efficiency in the context of the reviewers, means the people who are writing the comments online. So basically we'll say one reviewer is more efficient in comparison to other reviewer when he is producing more output, or at least same output for a lesser amount of inputs. Means either a reviewer, suppose I'm talking about two reviewers, reviewer X and reviewer Y, and we want to see how much efficient X is in comparison to Y. So basically what we are trying to see, how much how much output is being generated by consuming certain amount of input by reviewer X in comparison to reviewer Y. And if we'll declare reviewer X to be more efficient in comparison to reviewer Y, if either he is producing same output or more output by consuming less amount of inputs, or he is able to produce more output by using the same amount of inputs, or but by using less amount of inputs, giving more outputs in comparison to other reviewer. So this is basically we define the concept of efficiency with respect to online reviewer community. Now, for efficiency analysis, the tool what we have used, that is known as data envelopment analysis, is one of the most frequently used technique when we are talking about the efficiency analysis belonging to different domain, whether it is domain of marketing, it's a domain of finance, or it is domain of manufacturing. The data envelopment analysis is one of the most frequently used tool for that. Now, when we are talking about the reviewer efficiency, then the inputs what we have taken into consideration, because it's more about input-output analysis. So the input what we have considered here for the reviewer efficiency is that we are taking the characteristics related to the E1 text. And secondly, we have also taken to the consideration certain characteristics related to the individuals, whether it is their age, gender, location, like that, their experience level, the ratings, what they have, what others user have given to them, I'll be talking about this in the next slide. And the outputs, what we are using is that how much helpful other users have found that particular review, how much rating they have given to that particular review, and the batch level which has been assigned by the because my case study is related to TripAdvisor. TripAdvisor gives 5 levels of batches to its reviewer. So what kind level of batch has been assigned by the TripAdvisor to that individual? So at another output what we are having here. By using these input variables and output variables, we'll be able to assess which reviewer, the efficiency level of the different reviewers. Once we know the efficiency level of the different reviewers, we may be able to rank the reviewers. Once the ranking of the reviewer is obtained, then the marketer may plan to offer those reviews on the top, which are coming from the top reviewers. Means the reviewer with the rank higher, rank 1, 2, 3, like that, or which are efficient reviewers. The research methodology, what we are using this purpose, that basically first we collect the data. Again, the data has been collected from the TripAdvisor for this particular case study. And then for the efficiency analysis, we have extracted 11 input variables, which are related to the EWOM text and the reviewer text, reviewer characteristic, the individual characteristics. And there are 2 output variables. First variable is the number of helpful votes which are given to the reviewer by the other users, and the batch level which has been given by the TripAdvisor to that individual. Okay, now the data, whatever has been collected, it was cleaned, and ultimately after cleaning the data, we pre-processed the data, and ultimately what we were left with the data of 476 reviewers, and who have posted together more than 28,000 comments over the site of TripAdvisor. This is the description of those 11 attributes which have been used for the efficiency analysis. You can see out of these 11, 6 belong to the text, and they are related to the polarity. Basically, it shows the sentiment of the text. Then the length means the number of characters in the comment. Then the readability. Again, for the readability, we have to use FKGL measure to show how much readable the text is. These are the 3 characteristics which are related to text of the EWOM. More other 9 characteristics, other 8 characteristics are related to the reviewer, and they are basically shows that for how much time that individual is associated with TripAdvisor, basically the number of years, number of days of membership. The number of photos, that how many photos that individual had put on the website of tripadvisor.com. Recency is basically that what is the number of days elapsed since he have from the date of the problem, the data, to the date he has posted the last review. Helpful votes is the number of helpful votes received by the reviewer. This is the output variable. The batch level, the contribution level of the reviewer. I told you that there are 5 levels of the contribution which are given by TripAdvisor to the individuals who are writing the reviews over their website, and that is our batch. And this is again an output variable for our study. Other input variables are number of, which shows basically the experience or the travel experience of the reviewer, and they are related number of miles traveled by the reviewer. The other are related to the identity disclosure, that is the gender of the reviewer, the age of the reviewer. These 2 characteristics basically relate to the identity disclosure that they have disclosed their identity, whether they have given the data about their gender, whether they have given the data about their age. Then for the reviewer experience, again variable what we have included, that is a number of cities traveled by the reviewer and the number of EWOM posted by the reviewer. Again, it shows the expertise level or his travel experience. Because higher is the number of reviews posted by a reviewer, it means more extensively he has traveled. Similarly, more is the number of cities traveled, more will be his travel experience. Now, this is the summary statistics of all the input variables and all the output variables, you may see, that on the first column shows the summary statistics for the input variables, and for the second column shows the summary statistics for the output variables. So in all, this is the data of 476 reviewers, and together they have written more than 28,000 reviews. Now, after the extraction of all these input and output variables, now we apply DA model, data envelopment analysis. This is basically, it consists of formulation of a linear programming technique, where the efficiency, we try to maximize the efficiency score subject to certain number of constraints. And I'm not going to the detail of what is meant by data envelopment analysis. That is one of the well-known techniques for efficiency analysis. People may refer to any standard text for that. But I'll be talking about that once we apply data envelopment analysis to our problem. Okay, first thing is that because we had 11 input variables and 2 output variables. So by using these 11 input and 2 output, first we have built two models, two efficiency model. In first model, we had only we had 11 input variables with 1 output variable, and that is the number of helpfulness votes given by the other users to that reviewer. And in the second model, we used 2 in addition. We also want to see that how the different characteristics are, are determining their ranking. What role do they have with respect to, ranking of the reviewers? Means if we employ that method in real life, then what output variables should be included? So basically, by building 2 models, we are getting that opportunity to do a comparative analysis. Okay, so in the first model, 476, in both the models, 476 reviews are included and then ranked from 1 to 476. Please mind here that the reviewer who is getting rank 1 is basically the one who is most, who has done, well, who is more efficient, most efficient, while a reviewer who is getting rank 476 basically stands at the lowest level. So this is, that is one thing, because when we discuss the results, so this thing must be kept in mind. First, this graph basically shows that when we are, that how the efficiency score of 476 reviewers are changing when we had only 1 output and when we had 2 outputs. So basically shows that how the efficiency is changing. One thing which you can note here is that when we are moving from 1 output-based model to output-based model, then there is a significant changes which are coming in the efficiency score of the different reviewers. And plus, another key point is to be noted by looking at this graph is that when we are moving from 1 output-based to 2 output-based model, then there is a non-negative change. Non-negative change means either the efficiency score remains the same or it increases positively when we move from 1 output to 2 output based model. This is a I think I am taking too much time. This is I'll just show the graphs. This is the descriptive summary of the entire data. Sorry, I'm really okay. Just a minute. This is another graph which shows that how the ranks of the reviewers are changing when we are moving from 1 output model to 2 output based model. So again, we can see there is a significant, with a lot of variation in the ranks of the reviewers. But if Now, if we talk about this in terms of statistics, then we can see that out of, main thing is, you may refer to these tables, but main thing is that when we are talking about the reviewer efficiency and the role which are these different, 11 attributes we have included in the efficiency analysis, what impact those 11 attributes are having with respect to the efficiency of the review, the main thing which need to be, which we make out by doing this numerical is that age and gender, they are not affecting. They have no role to play with respect to the output related to the reviewers. Means they don't enhance. They have no role to play with respect to determination of the efficiency score of the different reviewers. It means it's not, if I talk about from an OTU perspectives, it's not important to know the gender and the age of the reviewer. If we see, if we talk about the different features, then you can see E-length and E-readability has more determining role as compared to the recency of the reviewer in determining the efficiency level. So basically, by comparing, by analyzing these tables, we may be able to understand that out of those 11 attributes, which attributes are playing more determining role, for the efficiency of the reviewers, and which have no impact with respect to the efficiency of the reviewers. So accordingly, the OTA or the portal which is maintaining this entire review system, that how, which key attributes should be taken to the consideration in ranking the reviewers, so that the reviews which are coming from the top reviewers can be shown first to the customers. That's all from my side. Thank you so much for joining. These are the other tables, which basically help in analyzing these. And these are the few references which people may go through, for the further understanding of the subject. Thank you so much once again for giving time and the opportunity to speak. Thank you so much. Any questions? I am ready to take up.
Thank you so much, ma'am. No. Yes, ma'am.
No, any questions from the audience?
As per now, I cannot see any questions in the chat.
Okay, thank you so much.
Thank you so much, ma'am, for gracing us with your presence. That was a really encouraging session. Finally, we're approaching to the end of the two-day
Thank you so much, Anu ma'am. Thank you very much for joining.
Thank you so much, Dr. Ashish. Thank you so much for inviting me and giving the opportunity to share my research.
Yes, ma'am. It was really a wonderful experience for all the audience, and we really means it was very enriching for all of us to hear you.
Thank you so much.
Yes, you can continue.
Okay, sir. Finally, we're approaching to the end of the two-day program of the ICICC 2022 conference. It is my pleasure to invite Dr. Ajay Jaiswal, sir, to take over. Dr. Ajay Jaiswal is currently serving as an associate professor in the Department of Computer Science at Shaheed Sukhdev College of Business Studies, University of Delhi. He is co-editor of 7 books and journals and author and co-author of several research publications in international journals and conference proceedings. He has completed an interdisciplinary project titled Financial Inclusion Issues and Challenges, an empirical study as co-PI. This project was awarded by the University of Delhi. He obtained his master's from the University of Roorkee, now IIT Roorkee, and PhD from Jawaharlal Nehru Institute, Delhi. He is a recipient of the Best Teacher Award from the government of NCT Delhi. He has more than 21 years of teaching experience. Currently, he is working as co-PI on major project titles, increasing the impact of government welfare policies for social and financial inclusion to technologies, technological integration in India. Awarded by the Indian Council of Social Science Research, ICCSSR. We welcome you, sir.
Thank you for a nice introduction, Devyanshi. Good evening, to all the participants of the conference. And I'm sure that during these 2 days, all of us had obtained an insightful concept. This was the 5th edition of the conference. That is main theme of the conference is innovative computing and the communication. And we have learned a lot from the keynote session delivered by our chief guest, wisdom thought shared by our patterns, general chairperson, interactive workshop session, and the other 4 keynote session delivered during the 2 days of the conference. Once again, on the behalf of the organizing committee, thank you for delivering such important materials so that all of us can deepen our knowledge about the new paradigms that are coming in the computing and communication world. Furthermore, I would like to thank all the presenters and the participants who have joined this conference from all over the world. I am certain that everyone has presented their best ideas in the relevant field to this conference. I sincerely hope that through your presentations and discussions afterwards, all of us can contribute in solving some of the important issues prevailing in the computing and communication world. I would like to mention that this is the 5th version of ICICC. This is organized in hybrid mode due to spillover of the pandemic situation. And we have put all the effort, and at this moment, I can say that this conference is a great accomplishment, and it gives me immense pleasure to announce that our conference is growing in leaps and bounds. This time we received 850 papers, and out of those, around 200 papers were selected and presented, and all the presented papers will be published as the proceedings of the conference. Finally, I would like to thank all the committee members for organizing this conference and ensuring that it proceeds smoothly. Once again, I thank all the presenters and the keynote speakers, our chief guest, Professor Ziyang Shao, Dr. Vinay Thakur, Professor Michlis, Professor Stefano, and Professor Anu Agrawal. I do also hope that we will meet again in the 6th version of this conference in 2023. Thank you all. Over to you, Divyanshi.
Thank you so much, everyone, for joining in. And this takes us to the end of ICICC 2022. Thank you all.
Thank you everyone, every participant to participate in ICICC and present the paper. So we are now closing the meeting. Ekansh,